Okay, so now we're on the back of this, of the notes. We have one more kind of theorem, postulate, that we're going to talk about, and then we'll look at some examples. And the postulate is called the Arc Addition Postulate. And again, a postulate is just, it's a rule that we assume to be true in geometry. So here's what it says. Let's read it and then we'll draw an example. The measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. Here's what it says. If you take a circle, okay, and we take a center, we can call it P again. So this is the circle with center at P. We're going to draw some central angles here. Let's draw one angle, and we'll name the points where the angles raise, or where the sides hit the circle, A and B. And let's draw one more angle here, and we'll call this point C. So A, B, and C, those are on the circle. Now you have three angles in this picture. You have angle APB, you have angle BPC, and then you also have the big one, angle APC. Let's take angle APB. This is a central angle because P is the vertex that's at the center. Let's say that this angle measure was 42 degrees. Let's also take angle BPC, and let's say that this angle measure was 63 degrees. Okay, the picture is not drawn to scale. Let me zoom in here a little bit, make it easier to see. So this is 42 degrees, and then this is 63 degrees. If you add the angles, now we talked about this in chapter 1, if you add the angles, if they're adjacent and you add them up, then the total would be 42 plus 63. That would get you the big angle. Okay, so if we say the measure of angle APB plus the measure of angle BPC equals the measure of the whole thing, which is angle APC. Now it's not 180 because 180 would be a straight line. Okay, so we have 42 plus 63, that equals 105 degrees. So that's the measure of angle APC. But those are central angles. And we've already talked about if the central angle is 42 degrees, then the arc measure is also 42 degrees. They're equal. The central angle is the same as the arc, as the minor arc. 63 degrees, BC is 63 degrees. The central angle is the same as the arc. So the rule that we have for angles also applies to arc measure. You can say the measure of arc AB plus the measure of arc BC. If you add these two smaller arcs, it has to give you the big arc, which is AC. So the measure of arc AC is also 105 degrees. Okay, so it's the same rule that applies. This is really nothing new. It's the same concept. If you add up the parts, you have to get the whole thing. That's always going to be true. Okay, so let's look at some examples here. Example number 1. You have the circle with the center at A. We want to find the measure of arc BC and the measure of arc BDC. Now when you do this, there's not necessarily any order to how you find it. Start with the numbers and then work your way from there. So they give us 94 degrees, which happens to be a central angle because the vertex is at the center. This is A. Well, if I trace out the sides of the angle, I'm going to hit the circle here at point B and then here at point C. So this arc between them, arc BC, is a minor arc. The central angle is 94. The arc measure is the same. It's 94 degrees. So the measure of arc BC, that's 94 degrees. We got that. Now we also want the measure of arc BDC. If we trace that, that means we start at point B. Here's B. Then we go to D. So we're going around this way. And then finally we end up at C. Now notice that with the red arc and the blue arc, the whole circle now is shaded. The whole circle is traced out. All the arc measures are always 360. So if this is 94, to find out what's left over, take 360 minus 94, and what we get is 266 degrees. So the measure of arc BDC, 266. And that's it. Let's move on to example number 2. Now they're asking us to find all kinds of stuff here. So let's go ahead and just take this picture and let's write down anything that we can find. And then we'll worry about writing down the answers at the end. Okay? Let's start with the measures that we know. They tell you 102 degrees, and this is a central angle. So again, if I trace this out from the vertex, I'd hit the circle at B and C. So the arc between them, arc BC, the central angle is the same as the arc measure. If this is 102 degrees, the arc measure is 102 degrees. Now one thing that you have to look for also, don't forget about things like diameters. EC is a diameter because it goes through the center and it has endpoints on the circle. And a diameter always creates a semicircle. And semicircles are 180 degrees. So if this is 102, to find arc BE, it's just 180 minus 102. And what we get is 78 degrees. Now what this also allows you to say, here's the arc measure, the central angle is here, it's the same, 78 degrees. That has to be true. Now let's see, what else do we know here? You have a central angle measure of 37. Well, what that tells you is that the arc measure has to be 37 degrees. So we know that. And then the last piece here is DC, arc DC. Now let me look at this a different way. You've got 37 degrees for this central angle measure. If I put this angle and this angle together, they're adjacent, notice that they form a straight line. So this right here has to be 180 degrees. So if I take 180 minus 37, we get 143. So this is 143 degrees. If the central angle is 143, the arc measure has to be the same. That's 143 degrees. All right, so now let's answer the questions here. The measure of arc BC, and that is 102. 102 degrees. The measure of arc BD, now BD is this whole thing right here. So B to D is 78 plus 37. 78 plus 37, and that gives us 115 degrees. The measure of arc BCD. Now BCD is the major arc going around this way. So it's this whole thing right here, BCD. You have to add up the parts to get the whole thing. So 102 plus 143. 102 plus 143, and that gives us 245 degrees. And then the last piece of this is the measure of angle CAD. So we start C, A is the vertex, right here, D. So it's this angle, and we already found it, it's 143 degrees. So with circle problems, you have to go step by step. A lot of times each piece is pretty simple, but it just gets confusing when you look at it as a whole. Okay, so write down what you can, get what you can, and then answer the question at the end. All right, we're going to do 2 more examples here. We'll do 3, and then we're going to write down one more thing, and I'll actually show you a couple of the problems off of your assignment. So number 3, the circle with the center at P, find X, Y, and Z. So we have 3 variables now. These are all degree measures. Now they only give you one number. They give you, this is 35 down here. And let me zoom in a little bit. Okay, So this is 35. Don't forget all the relationships that we've talked about with angles. You have a set of vertical angles right here. Vertical angles are always congruent. So x, you already know it, it's 35. X is equal to 35. Okay, now the other thing that they do, look in your picture, they give you a right angle box. Well, that has to add up to 90. So if this is 35 and this whole thing here is 90, to find this missing piece right there, okay, I'll put double arc there, we can do 90 minus 35. Okay, I'll do it up here, 90 minus 35, and that gives you 55 degrees. Now the way that that helps you, if you look at Z, this arc, there's Z, well, that gets created at this point and this point. Now where do they match up? Here, this angle right here, which is 55 degrees. So central angle is the same as the arc. That's 55 degrees. So we know that Z is 55. Now we need one more thing. We have to find Y. Now Y is over here. But let's see here. Let's use the arcs. We know that Z was 55. How about this small piece right here? It's got to be 35 because that's the same as the central angle. And you know that this whole thing, that's a semicircle. This is a diameter because it goes through the center. A semicircle is 180. So if you add these up, you get 90, which means that this is what's left over. 180 minus 90 equals 90 degrees. So your answer is, for y equals 90. Okay, that's it. Now let's just talk about one more thing here. We're going to put a number 4 on this. This is a vocabulary word. It's that you'll see this on your assignment in one of the questions. Concentric circles. Concentric circles. Okay? All that means is it's two circles that have the same center. Two circles that share the same center. So if you have a circle within a circle, and they both have the same central point, you would say that these are concentric. And as an example here, let's say that this central angle is 60 degrees. All right, so this is a 60 here, and then we'll say this is x degrees and this is y degrees. And we want to find x and y. Well, x is this arc measure. The central angle is 60, so the arc has to be the same. X is 60. But here's the thing though. To find y, that's also an arc measure. The central angle is 60, so the arc measure is still 60 degrees. Now you'd say, wait a minute, but this arc is bigger. It has a bigger distance, it has a bigger length, but it does not have a bigger arc measure. An arc measure is like an angle measure. Okay, so both of these are actually the same. X is equal to y in this case. Now I want to show you one example off of your assignment. Okay, so you'll get this worksheet here. This is on the back. And let's go ahead and look at a problem at the bottom here. How about something like, let's do 28. Let's do the very last problem, where you're dealing with variables. Okay? So you got your circle. Now let's see, what information do they label? They give you arc TU is negative 37x plus 2. All of these are degree measures. They don't put the degree there, but you can assume that that's an arc measure. You have negative 27x minus 3. Now the problem is that they don't put anything about this arc. They don't give you any expression, but they do show you at the center those are congruent. So if this arc measure is negative 27x minus 3, so is this one, negative 27x minus 3. All right, so let's see, how are we going to solve this? Well, what do you know about all the arc measure of any circle? Always. The arc measures always add up to 360 degrees. So we're going to do negative 27x minus 3. And then we're going to do plus negative 27x minus 3 plus negative 37x plus 2 equals 360. All right, that's a messy equation. Let's go ahead and simplify it. Let's combine all the like terms. Now, on the left side of the equation, let's put all the x's together. Negative 27x, negative 27x, negative 37x. Now, if we add that up, we get, let's see, negative 54x minus 37, negative 91x. Then you have minus 3 plus 2. So that's negative 3 minus 3 is negative 6, plus 2 is minus 4, equals 360. Okay, now that's a lot easier, that equation. Now what do? Let's go plus 4 plus 4. Move the constant. We get negative 91x equals 364. Last step, divide by negative 91. X equals negative 4. Wow, that actually worked out nicely. Not always the case. You can get decimals, but that works out pretty well. X equals negative 4. So the question is, are we done? Well, they ask us for the measure of angle VST. So VST is right here. Let's go back to the picture and let's substitute the number for the variables. So you have negative 27 times negative 4 minus 3. And when you do that, you're going to get, let's see, 108 minus 3. That's 105 degrees. So that's 105 degrees, that arc. The central angle has to be the same as the arc measure. If this is 105, this is 105. So the answer, measure of angle VST equals 105 degrees. Okay, so if I want to check it, this is 105, this is 105. This other arc measure up here would be 150. 150 degrees is what you get. 105 plus 105 plus 150 equals 360, and that is the answer.